Hello everybody. Now we're going to do some derivative practice. So we're going to see a lot of product, quotient, and chain rule, along with some trig and exponentials and logs. So the first one I'm going to look at is 4x cubed times sine squared of x. So x is being cubed and multiplied by 4, and x is being input into the sine function and then squared. So we should see that this is two functions multiplied by each other, which means we have to use product rule. So I'm going to take the derivative of the first term, sorry, not the first term, but the first function, if you will, get 12x squared, copy down the other one, then I'm going to add, I'm going to copy the first one down, 4x cubed, and take the derivative of the second thing. Now the second component is really sine of x quantity squared, so I've got to use chain rule on this. So I get 2 times sine of x, and that sine of x is now to the first. Then I take the derivative of the inside, which is sine of x. So the derivative of sine of x is cosine of x. So this is my answer based on calculus alone. Now I can clean this up a little bit, and I've got 12x squared sine squared of x. The 2 times the 4 gives me 8, so I've got 8x cubed sine of x cosine of x. And now I can do some factoring. So greatest common factor of 12 and 8 is 4. I've got x squared as my smallest exponent on x, and I can pull out a sine of x. Now 12 divided by 4 is 3. I still have a sine x on that first term. Go to the second term, I've got a 2x and a cosine of x. And there's my final answer, factored. If you need help on factoring, check out my little video on factoring. The next one, again, I see I've got x being put into this polynomial and x being put into this polynomial, cubed and squared respectively. Two functions being multiplied by each other. I've got product rule. Now, because they are being raised to powers, I've got chain rule within my product rule. So I take my derivative of my first term. I've got 3. Leave the inside exactly the same. Drop the power down 1. Multiply by the derivative of the inside. And that's the derivative of the first function. Now I simply copy the second function down, unchanged. Now I'm going to add to this. I'm going to copy the first function down and take the derivative of the second function. Sorry for the glitch. So now I've got to take the derivative of the second part, which is simply 2 times the inside stays the same. Drop the power down 1, which is just 1. Take the derivative of the inside. Now this is my final answer if I just did calculus alone and didn't want to bother to do the algebra. But we're going to clean this up. What am I going to leave totally untouched? I'm not going to touch the 3x squared minus 8x plus 5, and I'm not going to touch the 5x minus 3's because those are things I'm going to be factoring out. So I distribute my 3 to my 6x minus 8. I've got 18x minus 24. Copy the rest of the stuff down from the first term. Move on to the second term. I've got the 2 times the 5, gives me 10, and copy all the stuff that was left over. And now I'm ready to factor. So again, I'm looking at these components. Smallest exponent on those is 2 and 1 respectively. So I can factor out 2 of these guys and 1 of the 5x minus 3's. Then I'm going to write a bracket. What's left, I've got the 18x minus 24, and I've got 1 extra 5x minus 3. Get to the next term, I've got a 10, and I've still got a 3x squared minus 8x and a plus 5. So now it's just time to clean up the inside, which I really don't feel like doing. I will let you simplify this. You can just use Mathematica or Wolfram Alpha if you want, and whatever that simplifies to as one polynomial, just leave it, and that's your answer that you'd be looking for if this were a multiple choice question. So I will leave you to do that. Check out wolframalpha.com to simplify. Alright, the next one. I've got x being input into cosine, and then I've got x being thrown into the polynomial in the denominator. This is a function divided by a function. That is going to have quotient rule, but all this is to the fourth, so I've got chain rule. So my derivative, which I'm sorry I have not been writing my primes like I should be, I simply do 4, leave the inside exactly the same, drop the power down 1. Now I have to take the derivative of the inside. Low d high minus high d low, all over low squared. So I copy the bottom. And I take the derivative of the top, which is negative sine of x. Subtract the copy the top down, high d low. Derivative of the bottom is simply 10x minus 3. All over the bottom squared. There is my calculus answer. The rest is algebra. I will let you simplify the numerator of that exponent, but you would get 4 times cosine cubed of x over 5x squared minus 3x plus 2 to the 5th, because we've got it cubed here and squared here. And then you're going to have all of that is going to be times what I will let you simplify with algebra, all of this, which is really quite boring. In fact, I wouldn't simplify it at all, but that would all go right here. There's no simplifying that you can do that's meaningful. That would be your derivative. So again, we use chain rule, and then our derivative of the inside required that we do quotient rule because I had a function over a function. Alright, so on to this one. I would rewrite this problem as x squared minus cosecant of 3x squared plus 2 all to the 1/2, and then I see that x is embedded in this function, so I've got to use chain rule. So I've got 1/2, leave the inside precisely the same, drop the power down 1, and then multiply by the derivative of the inside. Derivative of x squared is 2x. Derivative of cosecant is negative cosecant cotangent, so the negatives cancel out, so I get plus cosecant of, whenever I take the derivative of a trig function, my input to that trig function and its derivatives remains exactly the same. So I've got cosecant cotangent both of the 3x squared plus 2. So that does not change on those inputs. Now I have to do chain. I still have to do chain rule, so the derivative of the inside is simply 6x. So I multiply this by 6x. And there's really nothing fancy you can do with this other than rewrite it as 2x plus, I would bring the 6x to the front, so I've got 6x cosecant 3x squared plus 2 cotangent of 3x squared plus 2 all over 2 times the square root of exactly what I started with, x squared minus cosecant of 3x squared plus 2. Alright, so that was a simple chain rule. Again, remember that whenever you take the derivative of a trig function, your inputs remain exactly the same in the derivative. They do not change. All right, the next one, I've got a function within a function within a function. So my outside function is cotangent. Derivative of cotangent is negative cosecant squared. So g prime of x equals negative cosecant squared. I need to keep the inside exactly the same. Tangent of negative x cubed. Now I work my way in. So derivative of tangent is secant squared of whatever the input was. So I've got secant squared. Its input is the negative x cubed. Now I move to the inside. Derivative of negative x cubed is simply negative 3x squared. So simple rewrite, I would probably do the negative times the negative gives me positive, and I'd pull my 3x squared to the front, and the rest is just copying down what I've already got. And I'm done. Not that bad. Alright, on to the next one. So I've got a natural log, which forgive me, but I am going to be lazy and continue to just say ln. So whenever I've got the derivative of ln of something, all I need to do is put that something on the bottom. So I'm taking the derivative, put that something on the bottom, and its derivative on top. Now the inside of this function, secant cubed, remember this is really secant of x all to the third. So I've got to use chain rule. So I get 3, drop the power down 1, so I get 3 secant squared of x. Now I have to take the derivative of the inside. The derivative of the inside is secant. Derivative of secant is secant tangent. So I get secant of x, tangent of x. This is my final answer with calculus. You should be able to clean this up very nicely, though. I've got 3 secants on top, 3 secants on bottom. Those will simplify to 1. So my final answer is simply 3 tangent of x. I love my natural logs, and I love my e's. Natural exponential function. So I've got e to the cosine of this mess. Derivatives of e are delightful. So f prime of x. I copy down exactly what I have. Now, chain rule says I got to multiply by the derivative of my exponent. So the derivative of cosine of something is negative sine of that something. Still need to move on to the derivative of the inside, so the derivative of the 3x squared minus 7x gets multiplied by this as well. I've got 6x minus 7. And there's nothing worthwhile of simplifying, but I would more commonly move this to the front and write the exponential after. And you will generally see that on an exam as well, but it really depends. You may not. So nothing exciting to do in terms of algebra cleanup. Now the next one, I've got natural log of something, so my rules say to do 1 over that something, which in this case means just flip this. So I've got sine cubed 5x over 4x cubed minus 8x squared plus 3. Now I have to multiply by the derivative of the inside, chain rule. Derivative of the inside requires that I do quotient rule. So low d high minus high d low. So I copy the sine cubed of 5x, multiply it by the derivative of the x at the top, which is 12x squared minus 16x. Now I need to subtract, so low d high minus high d low. That is not a parentheses. Now I need to think of the bottom as sine of 5x all being cubed, so it is chain rule. So I get 3 sine squared of 5x. Derivative of sine is cosine, so I get cosine of 5x. And derivative of the inside is 5, which, let's see if I got the room. Alright, so there's my numerator, low d high minus high d low, all over low squared, which is sine cubed squared, which would be sine to the 6th 5x. And there you have it. Now you can see that there's a lot of simplifying you could do here. You'd be able to factor out a sine squared of these two terms. You've also got the sine cubed here. So sine squared and sine cubed make sine to the 5th, which over the sine to the 6th mean you're just going to have a single sign on bottom. So let me go ahead and do that. So I've got sine of 5x times 12x squared minus 16x minus 3 times the 5 gives me 15. 4x cubed minus 8x squared plus 3. Pulled all those sine squareds out as I mentioned before, and this is all times cosine of 5x. This is all over 4x cubed. And I apologize, I am going to be updating my iPad. Upgrading, I should say. And then I just have the single sine of 5x on bottom. So again, I factored out sine squared on the inside, that numerator in the brackets, which left me with just a single sine of 5x times 12x squared minus 16x. Then I got the minus 15 by doing the 3 times the 5. Again, I factored out the sine squared, so that's gone. And then I still have the cosine and the 4x cubed minus 8x squared plus 3. And again, I still just have the single sine of 5x on the bottom. And life is good. Alright, another messy one. So, log base anything is essentially the same as natural log. I am going to write the inside on the bottom. So I've got the 5th root of sine of 3x on bottom. But I'm going to write that as sine of 3x to the 1/5. Or I could write sine 1/5 of 3x. I don't know if that's commonly written or not. So that goes on the bottom, and I need to multiply by the derivative on top. But I also have to divide by the natural log of my base, which is 3. That's the only difference. Otherwise, you would divide by ln of e, which is just 1 when you're looking at natural log. So now all I need to do is take the derivative of, let me circle it. I'm basically taking the derivative of this, and that's going to go on top. And that was not at all what I wrote. So I'm going to have 1/5 sine of 3x to the negative 4/5 times derivative of sine of something is cosine of that something times derivative of the inside is 3. So this one I can do a lot of cleaning up. I've got 3 cosine of 3x on top. I move the 1/5, I move the 5 to the bottom, and I move the sine to the negative 4/5 to the bottom. So negative 4/5 minus 1/5 is negative 5/5, which is negative 1, which means I've got a sine of 3x on bottom. and then I would have probably written the ln of 3 at the front. So I would have written 5 ln of 3 sine of 3x. But this is a final answer that is acceptable to me. Alright, last problem I've got is just a mess. You've got a function being divided by a function. The function on top, though, is a function multiplied by a function, so you've got product rule there, and those are each being raised to a higher power, so those each have chain rule. Then on bottom, you've got two functions as well being multiplied, so you've got product rule there, as well as chain rule. So this is product and chain within quotient. And I'm probably not going to bother simplifying it just because it's messy, because I threw in that 7 to the power of negative x squared plus 3. So, low d high, copy the e to the 3x plus 5, 7 to the negative x squared plus 3. Times d high. I'm going to put it in brackets. So I'm going to have 3, that quantity to the second, and then times the derivative of the inside is 5. So I'm really going to have 15, 5x minus 3 squared. Copy down the other part. Plus, so again, I'm just working with the derivative of the top, so that's why I'm not subtracting yet. Now the derivative of the second part is going to be 3 times 9x plus 3 squared times the derivative of the inside is 9, so 9 times the 3 gives me 27. So I've got 27, 9x plus 3 quantity squared. And I copy down the other part, 5x minus 3 cubed. Did I leave myself enough room? Who knows? So that is low d high. Now I need to do minus high d low. Let's see if I can remember what I had. I had 5x minus 3 cubed and 9x plus 3 cubed on top. So minus high, derivative of the bottom. Since I'm limited with my capabilities of what I can do, I'll write the bottom here so I can work with it. I hope. So times derivative of the bottom. Again, I got to use product rule. So I'm going to have 3 e to the 3x plus 5 times 7 to the negative x squared plus 3 plus, so this is still in the square brackets, I'm going to have the natural log of 7, and that's from my derivative of a number other than e raised to a power. So natural log of 7 times negative 2x, that's the derivative of the exponent, 7 to the negative x squared plus 3. I got to move this over. Whoa, I am struggling to select. There we go. So this is all still in the bracket. So let me make that bracket hideously hideous, just awful. So again, derivative of e to the 3x plus 5 is just e to the 3x plus 5 times the derivative of the exponent, which was 3, copied down the 7 to the negative x squared plus 3, plus the derivative of 7 to the negative x squared plus 3 is 7 to the negative x squared plus 3 times the derivative of the inside, which is the exponent, so that's negative 2x, times the natural log of the base, and then I multiply that by the other function. Now, all of this goes over my bottom squared. E to the 3x plus 5, 7 to the negative 7x squared plus 3, quantity squared. And that's just too messy to bother simplifying. So there you have a few examples of derivatives in calculus. Thank you for watching.